Hey calculus students, we are still in Unit 0, our prerequisite unit, kind of reviewing things from Algebra 2 and Pre-Calculus. This video is on algebraic simplification, which is a lot of factoring and simplifying expressions using algebra. It's a pretty long video, so we're actually going to skip our warm-up and just get straight to it with factoring. So factoring, a definition you can think of is splitting up an expression into multiplication of similar expressions. So whenever you see this word factors, it should be made clear that that is like multiplication that's happening. Okay, so factors are always multiplication of different expressions. And so one way that you can think of it is it's the opposite of the distributive property. So you can see going from left to right, the red arrow shows that in order to expand the expression, you apply the distributive property, and then going right to left, to condense it into simpler expressions that are being multiplied, that is factoring. Okay, so sometimes we will want to expand and distribute, other times we will want to factor and make the terms simpler. So let's review let's review two types of factoring. The first is probably the first type of factoring that you learned about. It's greatest common factor, and that is just when you factor out the greatest term that divides each term in the expression. So that means we have to look at each of the terms. So in A we have 50x and 80y, and we have to figure out what's the greatest term that I could divide each of those by. They don't have much in common, but I know that I can divide 50 and 80 both by 10. So I'm going to factor out 10, and then I'm going to write what I have left over in each expression. So 50 divided by 10, is 5x, and then 80y divided by 10 is 8y. And looking at 5x and 8y, there's nothing else I could divide them by, so I have factored this as fully as I can. So you see it's simpler terms being multiplied times each other. Okay, part B, a little bit more complicated. Here are my two terms. I'm going to take this step by step by looking at the numbers, then the x's, then the y's. So the numbers 27 and 72, I know that they're both divisible by 9, so I'm just going to start with 9. I'm going to factor out 9 from each of those. The x's, I see I have x squared and x cubed, so that means I can divide out x squared. It's the greatest term that I could factor out. And then I see I have y to the 5th and y squared, and so I can factor out y squared. Now I'm going to figure out what I have left over. So 27 divided by 9 is 3. The x squared divided by x squared disappears, so that's gone. And then y to the 5th power divided by y squared is y to the 3rd power. So that's all that's left in that term. The second term, 72 divided by 9 is 8. X cubed divided by x squared is, x. Y squared divided by y squared is nothing, so that term disappears. And now looking at the terms that I have left over, I see they don't have any other common factors that I can divide out. So this is that is factored form. It's now two simpler terms being multiplied times each other. Part C, I'm going to let you try on your own, so you should work on part C individually and then compare with my answer. One common mistake with part C would be to not include this plus 1. It is very important we still add 1 because 4x cubed divided by 4x cubed is 1. So we still have to add plus 1. But that is as simple as we can go. That's factored form. The other type of factoring is factoring quadratic expressions with Xbox, or just in general factoring quadratic expressions. So a quadratic expression is when we have like x squared, x squared makes a quadratic, it makes a parabola, so that is a quadratic expression. And generally you see it in the form a, I'll add it to the notes. So quadratic expression is in the form a times x squared plus b times x plus c. Hopefully that's familiar to you. So part A, I'm not going to use Xbox because I want to show you what the goal should be with factoring. The goal with factoring should be that you're able to determine, okay, I need to be multiplying two things since it's a quadratic. Quadratic means 2, right? X squared. I know that there will be b's in the beginning. I know that whatever I multiply at the end has to multiply to be 7. So 1 times 7 will equal 7. And then I know if I were to redistribute this, 1 times b and b times 7 is 8b. So this is the goal of how you should be factoring, just to know, oh, this is b plus 1 times b plus 7. I'm done. And I know some of you can do that. I know some of you are not quite there, and maybe you're dependent on Xbox. That's fine. Honestly, I just want you to be able to factor, but this is the quickest way of factoring. For those that don't remember Xbox, I'm going to model that in B. So part B is a expression that's a little bit harder to factor. Some of you might not be able to do that in your head, and you'll want to be able to use Xbox to help you out. Okay, so a reminder, the way that Xbox works is we make an X. Wow, my X is very dramatic. And at the top of the X we have A times C, and at the bottom is B. And so I'll just, in red, remind you, so we're using our quadratic form. So in this case, A is 2, B is 7, and C is 3. So I'll fill in my box. A times C is 6, and then, or I'm filling in my X, and then B is 7. Okay? And then in the two sides, I need something that multiplies to equal 6 and adds to 7. Okay? So if you need that reminder, what multiplies to 6 and adds to 7. Okay, so what multiplies to 6 and adds to 7? That would just be 6 and 1. So 6 times 1 is 6. 6 plus 1 is 7. So those are my magic numbers. And so I'm going to use those magic numbers to help me fill in my box. So in my box, we'll go 2, m squared, and 3. So these terms, oh, I don't want to use blue. I'll highlight in yellow. So these terms just go right here in your box. And then my magic terms, 6m and 1m, come from my x. So the whole point of the x, of doing this, is to figure out what goes in this part of your box. Okay, so the yellow highlighted comes from the original equation, the blue highlighted comes from my box, or comes from my x. Okay, and now it's time to find our factors. So to find, this is like a multiplication box, so to find what goes in my factors, I need to fill out the outsides of the box. So I need to find all what goes on the outsides of the box. So I know to get 2m squared, I have 2m times m. So 2m times m. And in this case, it is important where I put my 2m and my m. So if I put it here, yes, 2m times m is 2m squared. But you can see when I try to multiply across, like what times 2m equals 1m, that would be 1/2. And I want to avoid fractions. So I'm actually going to put my 2m at the top, up here, because then when I multiply across m times 1m, I can just write that's 1. Right? And then 2m, what times 2m equals 6m? That would be 3. and then I can check my last box. 1 times 3 does indeed equal 3. So everything in the box multiplies to get what you have inside, and then those are my factors. So these were positive numbers, so that will be addition. So from my box, I get the factors 2m plus 1 times m plus 3. So in case you weren't able to do the factoring in part B in your head, hopefully this review of Xbox will help you to be able to factor anything that you could possibly want to factor. Though the goal is to do it in your head. Okay. So we have one more example of factoring, and this is kind of the type of problem where all the factoring is leading. So on the AP exam, you're not going to have a question that's just asking you to factor. That's not going to happen because that's an algebra skill. But on the AP exam, you might have something like this that you will need to be able to simplify and factor. So the point of being able to factor is to simplify expressions that look like this. So we're going to simplify this expression by factoring. So I need to factor the top and the bottom. So the top is x plus 3 times x plus 2. The bottom is a perfect square, x plus 3 times x minus 3. And so the simplification process happens right here, where I'm able to cancel out my x plus 3 over x plus 3 because they make a giant 1. So I'm able to cancel it out because they divide by each other and form a 1. So this simplifies to the expression x plus 2 over x minus 3. So you have to be able to factor to simplify stuff like this. Cool. So moving on to our next algebraic strategy, which is simplifying complex fractions. So a complex fraction is a fraction that either the numerator or denominator has a fraction in it. So it looks something like this, just in case you need a visual aid. This is a complex fraction because there are fractions inside of fractions. Okay? So there's two methods for solving these types of fractions. Method 1, multiply the reciprocal by the denominator of the denominator. So multiplying by the reciprocal of the denominator. I know a lot of you know how to do that method, and it is easier in some cases, but it doesn't always work. Okay? So in cases where you can multiply by the reciprocal, you should do it, but it doesn't always work, and that is when you'll have to use method 2. So method 2 is to multiply the numerator and denominator by the least common denominator, or LCD. So this can involve more thinking, but usually there's less simplification involved, and it always works. So this is kind of a foolproof method that does involve a little bit more strategy, but it does always work. So in this first problem that we have here, I want you to look at it and kind of just think, which method do you think will be easier in this case? Okay. Here is the work for both methods. So method 1, you can see here is my denominator, and here they just multiplied times the reciprocal of the denominator. So they multiplied by the reciprocal. It looks like they simplified some things first. So they simplified 3y and 6y. So 6y divided by 3y is 2. And then x cubed divided by x, we'll just make an x right there. So that's how they got 2x over 1 times 2 over 1, which is 4x. So I think a lot of you probably like this method better, and the reason why we were able to do it is because it was just a fraction over a fraction, multiplied times the reciprocal. That method works. Method 2 also works fine, it just requires a little bit more thinking. So multiplying by the lowest common denominator, you just have to think, what is the lowest common denominator? So looking at the two denominators, or the least common denominator, I can see that the least common among them is the 6y, so it will be the bigger number, usually, the bigger number that includes everything in it. So 6y will be able to cancel out 6y. It's why they chose it. So this cancels out. And then it also cancels out the 3y, though it leaves a 2 behind. So a 2 gets left behind in the numerator, which is how we get 4x cubed over x squared, which is 4x. So both work. Use the method you like better. You choose. In this case, you choose. The next problem is a little bit trickier. So this is still a complex fraction, but you see it's not just a fraction over a fraction. It has these plus ones with it too. So it has other terms that are being mixed in. That makes it a little bit more complicated. So in this case, which method do you think will be easier? If you said multiply by the reciprocal, you are wrong. That method is a nightmare in this case. So here, method 1, you can see like barely even fits on the screen. I'll put a little division mark. Method 1 barely even fits on the screen. So honestly, I don't even recommend you write it down. I just want to show you that multiplying by the reciprocal can be a nightmare. Because in this case, since they weren't both fractions here, we actually have to do a lot of work first to turn them into fractions. So we had to add the numbers together. And so right here is actually the first step where we could multiply by the reciprocal. So frankly, I don't even recommend writing this method down. I recommend learning better how to do this one. So they looked at what was in the denominators, x squared and x. They determined the least common denominator was the more inclusive one, x squared. So you multiply by x squared, and things cancel out. So in this case, this x squared cancels out, but you still have to multiply it times the 1. And in this case, the x cancels out, but you still have to multiply times x, and you have to multiply 1 times the x squared, right? So just don't forget to distribute to all the terms inside. And so that's how we get x squared plus x in the numerator, and then x squared minus 1 in the denominator. At that point they factored. Ooh, our factoring skills. They factored, they're able to cancel out x plus 1 to get x over x minus 1. So I recommend you copy down method 2 to learn that one a little better. Now we've got to try. We've got to try, and I want us to think about which method will be easier. So let's look at just part A for now and think, okay, which method will be easier? Should I multiply by the reciprocal, or should I use the least common denominator? And in A, either will work. I think you all are more comfortable multiplying by the reciprocal, and we can do that in this case. So since it's just a fraction over a fraction, we can multiply by the reciprocal, and I think you like that method better. So we're going to do that. So instead of dividing by this, we're going to multiply times the reciprocal, which is x minus 1 over 2. So this will equal 3x minus 1 over 2x squared minus 1, which is more simplified, but I see that I can factor that term in the denominator. I see I can factor this term down here, so I'm going to do that. So this becomes 3 times x minus 1 over 2. This is another perfect square, so this is x plus 1 times x minus 1. And look it, I can cancel these out because they make a 1. And so this equals 3 over 2 x plus 1. There it is. Okay. Part B. Do you think we can multiply by the reciprocal with part B? I mean, we could. We would have to do some work first, though. We would have to add together the fractions and subtract the fractions. So we would have to do a little work before we could multiply by the reciprocal because we would need to combine everything together. So I'm going to try to use method 2 instead, and I'm going to multiply by the lowest common denominator, the least common denominator. So something that will cancel out both 3 and 4. So what will cancel out 3x and 4x? And if you're not sure, you can multiply them together. So in this case, the lowest common denominator would be to multiply times 12x. 12x will cancel out 4 and 3. Okay, so we've just got to make sure to use our parentheses and distribute to everything. Okay, so this will be 12x over 4x plus 12x over 3x. I'm showing all the work. You could also do some of this work in your head, because I'm sure some of you are already canceling stuff out. So 12x divided by 4x is 3. 12x divided by 3x is 4. 12x divided by 4x is 3 minus 4. So this is 7 over negative 1, which equals negative 7. Okay. So those are the two methods. You should know both of them, because sometimes different methods will work better in different cases. It just takes practice. So make sure that you understand this video before coming to class, and we will practice these challenging skills. Okay.